Good morning. Okay, we are going to learn the RC circuit, which can model as a first order differential equations. So as you know that by using Kirchhoff voltage law, you can know the voltage drop across resistor given by we denote the voltage drop across resistor VR is actually IR. Voltage drop across inductor L, which is actually VL equal to L di dt. Voltage drop across capacitor, we denote as VC is actually, we may have 1 over C integral I dt, or you want to find in terms of charge, then VC is actually also also equal to Q over C, and we have relationship between current I and charge Q is actually I is a rate of change of charge. I is dq dt. So for example, given R is 3 ohm, C is 0.25 farad, ET is 20 T volt, model the RC circuit as a first order differential equation and finds the current I if there's no initial current flows at initial states. Means when T0, there's no current, so I will be equal to 0. Or sometimes they put in the form I bracket 0 equal to 0. The same meaning T0 I equal to 0. First of all, we have to model it as a first order differential equation using the Kirchhoff voltage law here. So we have RC circuit, so you have VR plus VC equal to ET, because this is a series circuit. Then you know VR is actually IR. VC, we want to find current, that's why we use 1 over C integrate I dt equal to ET. We want to find the I. So you have to eliminate the integral by ddt verb hand side. So ddt verb hand side R, C, are constant. That's why you have ddt I, you have di dt. And then when you ddt with the integral, I make it slower. So mean to find in terms of I in ddt verb hand side. So your ddt IR 1 over C is constant. So your ddt integral I dt equal to your ddt et. So R is constant, so we factor out R. So ddt I is actually di dt. ddt integral I dt, you get I. So this so equal to E prime T. Equal to E prime T. Then you plug in the R, C and E and ddt the ET given. To plug in R, in this case is 3. We have 3 di dt. So your I is C is 0.25. E prime T is your ddt 20t, you get 20. So we make the first derivative become 1 unit by dividing both hand side by 3. So you got di dt plus 0.25 is 1 over 4 of 4. So 4 divided by 3, I equal to 20 divided by 3. You notice, this is 1/4 of 4. So divide by 3, 4 over 3, so 20 divided by 3. So this is a first order differential equation in terms of current I. Okay. As in the RL circuit, as I mentioned, okay, if your right hand side is constant, it can be treated as a separable equation and also linear equations. So first of all, we look at this one as a separable equations. Separable equations. If you rearrange as di dt equal to 20 minus 4i divided by 3. So this is only function of I. So function of I bring to the I, so dt you bring to right hand side. Then you will have, okay, di divide by 20 minus 4i. And then dt divide by 3. Let us bring this one, 20 minus 4i to di. 1/3 maintained in the right hand side. Then you integrate both hand side. So to integrate this one, as I said, you may use substitution techniques. Let the u equal to 20 minus 4i. So du will be negative 4 di. So you notice you have di, right? So di will be du divided by negative 4. Hence, your di divided by 20 minus 4i. Di is a du. Di is negative 1 over 4 du. And then your 20 minus 4i is u. This way you get negative 1 over 4 ln u. Replace back the u is actually 20 minus 4i. This is using substitution technique. So this one you get negative 1 over 4 ln 20 minus 4i. So integrate 1/3 dt, you have 1/3 t plus c. Okay, and then we'll eliminate the negative 1 over 4 by multiply both hand side by negative 4. So this you will get ln 20 minus 4i equal to negative 4 over 3t, negative 4 over 3c. Okay, and then you take exponent both hand sides. We have exponent ln 20 minus 4i equal to exponent negative 4 over 3t minus 4 over 3c. Exponent ln you get only 20 negative 4i. Because exponent ln fx you get fx. So 20 minus 4i, and then exponent here, you can break it as using index rule. Let's say you have ex plus y, it will be ex times ey. So exponent negative 4 over 3t multiply exponent negative 4 over 3c. Okay, this one is a constant. Let's rewrite it as a. So a exponent negative 4 over 3t. This is 20 minus 4i. So you want to solve for I. So make I as a title. So you have, first of all, 4i is 20 minus a exponent negative 4 over 3t. So the I will be 20 minus a exponent negative 4 over 3t divided by 4. And this is general solution. So notice first order you have one integral constant. And given the initial conditions t0, I equal to 0. That's why plug in I0. So 20. When t0, remember exponent 0 is 1. So you got 20 minus a divided by 4. So a equal to 20. Plug in a, you will get particular solution, which is I equal to 20 minus 20 exponent negative 4 over 3 t divided by 4. Okay, simplify it, you will get 5 minus 5 exponent negative 4 over 3 t. Okay, you may factor out the 5. You have 5, 1 minus exponent negative 4 over 3 t. Okay, this is using separable equations. And notice this one is also a linear equation. You may solve it using linear equation, which is much simpler. So now we solve it using linear equations. Linear equations, where we have the equation di dt plus 4 over 3I equal to 20 over 3. Remember, this is the PT. This is the QT. Then you have the form di dt plus PTI equal to QT. Okay. So first step identifies the PT. So your PT in this case is 4 over 3. Now this is linear equation. Step 1, identify your PT. QT. QT is constant 20 over 3. Step 2, integrates the P respect to T. So integrate 4 over 3 respect to T, you got 4 over 3 T. Step number 3, the integrating factor I is actually equal to exponent integrate P dt, so it will be exponent 4 over 3 T. Okay, step 4, put it here. Step 4, the solution of the linear equation is given by the integrating factor I. We want to solve for the current I, so this is a current I. The I is an integrating factor equal to, integrates the integrating factor I multiplied by QT dt. So the integrating factor is exponent 4 over 3t multiplied by the current I equal to, QT is constant, so I can factor out constant. So integrates exponent 4 over 3t dt. Constant time exponent. Okay, exponent 4 over 3t, so I factor out exponent. Then you can easily integrate exponent 4 over 3t. You get back the same form, exponent 4 over 3t. For integration, you divide by 4 over 3. 3, 4, 5, integrate, and then plus c. That's why we have 5 exponent 4 over 3t plus c. remember this is actually exponent 4 over 3t multiply I. So you want to solve for I, divide both hand side by exponent 4 over 3t. We have 5 exponent 4 over 3t. Okay, divide both hand side by x. Okay, this one divide by exponent 4 over 3t. So c divided by exponent 4 over 3t. So that's why you get the answer is 5 plus c exponent negative 4 over 3t. And you see general solution for separable and linear equation may have different form. This one is simply 5 minus a over 4. But this 5 plus c is exponent negative 4 over 3t. Because the a in your homogeneous equation and c may have different value. Okay, but the particular solution will be same. Okay, so this is general solution. So t equal to 0, we have I equal to 0. Hence, okay, this is I, 0 plus 5 plus c. Because exponent 0 equal to 1. Okay, 0, okay. 0 equal I0 equal to 5 plus c. So c equal negative 5. Plug in c, you get particular solution. So I equal to 5 minus 5 exponent negative 4 over 3t, or factor of 5 you have 1 minus exponent negative 4 over 3t, which is the particular solution. The next way, general solution look like different form, but particular solution will same. So we have moderate scale, the RC circuit as a first order differential equation. Okay, and then the E prime t will get constant. That's why this first order differential equation can be treated as separable equation and linear equation. If the right hand side is not constant, then it can only be linear equation. So separable, okay, you just bring the function of I to di, okay, the function of t to dt, and then you just integrate both hand side. For linear equation, we have di dt plus pti equal to qt. So this is a linear equation. So identify your pt, qt. Second step, integrate the p to t. Third step, gets the integrating factor, which is exponent integrate p dt. Okay, step 4, the solution of linear equation will be integrating factor I. Okay, multiply the variable that you're going to solve, current I, equal to integrate of integrating factor times qt dt. Okay, don't forget to put in plus c. If you don't put in plus c, then you don't have the integral constant for solution of first order differential equation. So you get a general solution for first order. We have one integral constant. When you plug in initial condition, we get particular solution. Okay, the same RC circuit. Now we would like to find the charge Q. The charge Q. So also model the RC circuit as a first order differential equation. Okay, and there's no initial charge at initial state. In t0. Q equal to 0. So the same thing, okay, now is only we are going to solve in terms of charge Q. So again we have VR plus VC equal to ET. So VR is IR. Okay, we want to solve in terms of charge, so VC we use Q over C equal to ET. Okay, and we know, okay, I is actually dq dt. So hence I here change to dq dt. So if you solve in terms of charge q, so you notice right hand side is et, because we just replace I here by dq dt. If we solve in terms of I, right hand side is e prime t, because Vc is 1 over c integrate I dt. And then I will differentiate, okay, both hand side I become di dt. So this is I over c. Then you compare, okay, with solving for current. We get R di dt plus I over c equal to e prime t. If you solve in terms of charge, is R dq dt plus q over c equal to et. So make sure you take note on it. Okay, so now we plug in the RC and ET value. So R we have 3 dq dt, C 0.25, ET is 20 t. And then we eliminate or divide both hand side by 3, so that coefficient for dq dt will become 1 units. So we have, this is, okay, 0.25 is 1 over 4, so it becomes 4 over 3, q equal to 20 over 3 t. Okay, as I said, if the right hand side is no longer constant, it can only be linear equation, because in this case it's impossible for you to separate function of q to dq, function of t to dt. Okay, let me try to show you. Let's see, if you want to make it as separable, this round is impossible. Because here, this one is a minus, we got t and q, the whole thing here. Because normally we bring the whole numerator, let's say either you to this side, you bring this one, you got t and q, how to bring to dq. You keep it here, you got t and q, how to keep it to dt. Constant doesn't matter. Previous one, because this one is only 20, let's say 20, so then you can bring the whole thing here to dq. But here, because you got this t, and here q, if you want to bring this to dq, cannot, you got t. You want to keep it to dt, you got q. So this is not separable equations. So it's normally, if the right hand side is not a constant, it is not separable equation. So in this case, it can only be linear equations. So this is actually linear equation only. This is only linear equations. Okay. Whereas your pt is actually 4 over 3. qt, now you have function of t, 20 over 3 t. So integrates of p dt, you get 4 over 3 t. Okay, the integrating factor, exponent integrate p dt, you have exponent 4 over 3 t. So the solution will be your integrating factor. Now we want to solve for q. So iq equal to integrates the integrating factor I multiply qt dt. This is charge q. This is the heavy capital Q. Confused. This complete lowercase and okay. So plug in the integrating factor, exponent 4 over 3 t multiplied by the charge q, integrate, okay, integrate exponent 4 over 3 t, qt is 20 over 3 t dt. So 20 over 3 you can factor up. So 20 over 3 integrate exponent 4 over 3 t dt. Okay. So now you have the product form of t polynomial multiplied with exponential form. Okay, I'm going to integrate it using tabular method. Okay, where the tabular method, okay, we have the sign, we have the u, we have the dv. Sign start from positive. Okay, if we got polynomial, u will be always chosen as as polynomial, hence exponential as the dv. So sign alternate. For u, you differentiate. Okay, if you got polynomial, then you differentiate until it gets to 0. dv you integrate. Okay, tabular method is actually a systematical way of integral by parts. So this one dv is integrate. So you divide, okay, divide by 4 over 3. So actually you got 3 over 4 exponent 4 over 3 t. So in differentiate 1 you have 0. So if polynomial you can differentiate until 0. If u here is not polynomial, let's say this is function of sin or cos, okay, then you just need to do 3 rows. Then you integrate again, so this will be 9 over 16 exponent 4 over 3t. Okay, the horizontal carry the symbol integral because this 0, that's why gone. So the result you have these 2. Put it here. This one, integrate t exponent 4 over 3t dt. Okay, the result follows the arrow, positive times t times this one, 3 over 4 exponent 4 over 3t multiply t. The second result is negative. We already factor out this one. This one you factor out 3 over 4. So you still have negative 3 over 4. So this is t. First result. T times 3 over 4 exponent 4 over 3t. Second result. Okay. So negative 3 over 4 times 3 over 4. Negative 9 over 16 exponent 4 over 3t. Okay. And said if you got polynomial, then you differentiate until 0. And the last row is actually the horizontal row. Is actually you have follow the pattern here. We have plus 0 times this one. So means 0 times 9 over 16 exponent 4 over 3t dt. That's why this one gone. This one gone. Okay, if you got other, okay, let's say u is a sin or cos, then you just need to do 3 times. Okay, or you sin cos also 3 times. Cos, you get back the same pattern in the first row, same pattern, is same form. Coefficient of cos different. So the horizontal row carry the integral symbol. Okay, this integral and you collect together with this one. So for polynomial, we just differentiate u until 0. The last row, because you got 0 integral, so you just get the slanting arrow as a result of your integral. Okay, hence this one you get the result 20 over 3 integral t, and this one the result is here, time 3 over 4. We have t minus 3 over 4. Remember, okay, plus a c. So we have the result is 5. Okay, 5, and then t. Oh, sorry, we still got here this term, exponent 4 over 3t. This is 5. That's why you have 5 exponent 4 over 3t multiply t minus 3 over 4 plus c. Okay, and remember this one. Okay, this is not q. This is exponent 4 over 3t cube. That's why the q, you divide both hand side by exponent 4 over 3t. So this one divide by exponent term, this one cancel. You got 5t minus 3 over 4. C divide by exponent 4 over 3t becomes c exponent negative 4 over 3t. Okay, and then you can see the next row. Now, when t equal 0, q equal 0. So we have 0 equal to 5t0. So this one 0. So only 0 minus 3 over 4 plus c. But exponent 0 is 1. That's why you have c equal to 15 over 4. So okay, plug in the q, the c to the q. So you got 5t minus 3 over 4 plus 15 over 4 exponent negative 4 over 3t. So this is a particular solution. You can check it. As we know, I is actually dq dt. That's the same RC circuit. If we solve in terms of q, we get here. Okay, initially we solve in terms of I. So we are going to check whether the I, if we get it from dq dt, will be same as what we model the RC circuit directly in terms of I. The differentiate q respect to t. So you have 5. Okay, so 5 because ddt t you have 1, this one is 0, so 5, and then you differentiate here, you have negative 4 over 3, 5, 15 over 4, exponent negative 4 over 3t. So you get 5 minus 5, exponent negative 4 over 3t. Okay, factor out 5. 1 minus exponent negative 4 over 3t. Let's check whether initially if we model the RC circuit directly in terms of I in example 1, yeah, we get the same thing. 5 times 1 minus exponent 4 over 3t. So mean the same RC circuit, if we want to find the current I, straight away you model it as a, in terms of I. If you want to solve in terms of charge Q, you model it in terms of Q. Okay, but after we obtain the Q, I just purposely want to check whether the Q that I obtained is correct or not. As I know dq dt equal to I, so I differentiate it, I will get I. Okay, and this I check it with the example 1 where I model directly RC circuit in terms of I, which is tally. So mean it is actually tally with example 1. So it's correct, so my Q. Okay, the third example from the same RC circuit, we can model in terms of VC, which is a voltage across capacitor. So again, here, now the same RC circuit we have seen, we can model in terms of current, charge Q, and now the voltage across capacitor VC. Okay, so we have RC circuit VR plus VC equal to ET. Okay, VR is IR. Okay, VC. We want to solve in terms of VC, so I maintain VC equal to ET. And you know, VC is actually 1 over C integrate I dt. Integrate I dt. When you look at back your RC circuit, you have the same I, right? I that flows through resistor and capacitor are the same. So it's the same I. Right? In I flow in, resistor and resistor are the same. So I'm going to take the I, solving I from VC here. To get the I, you have to ddt, or you C VC first, C VC equal to I dt. C is a constant, so I ddt VC, and then I ddt integral I dt. So that's why you get C d VC dt equal to I. When you ddt, you need with integral, we just left I. That's why we replace I is actually I. Now you replace I by this. So you have R C D V C dt plus VC equal to E T. So the same RC circuit, if we model it as in terms of VC, we get RC dVC dt plus VC equal to ET. If we model as in terms of I, we get R di dt plus I over C equal to E prime t. If we model in terms of charge Q, you get R dq dt plus Q over C equal to ET. Okay, so now we plug in the R, C and ET value. Okay, so R you have 3, C is 0.25, so dVC dt plus VC equal to ET is 20t. So this is actually 3 over 4. Mean here we got 3 over 4. This is 0.25 is 1 over 4. So you get this one is actually 3 over 4. 3 over 4 dVC dt plus VC equal to 20t. Okay, makes the coefficient for first derivative as 1. So you get dVC dt plus 4 over 3 VC equal to, we have 4 over 3 times 20t, which is equal to 80 over 80t over 3. So again, the right hand side is not constant, so this is only linear equation. If your PT is actually 4 over 3, QT is actually 80t divided by 3. Then you integrate P dt, you have 4 over 3t, and then the integrating factor I is exponent integrate P dt. We have exponent 4 over 3t. Okay, the fourth step, the solution. We are going to solve for VC, so you have integrating factor I multiply your VC equal to integrates the I multiplies the QT dt. With enough space to write. So plug in the integrating factor I is exponent 4 over 3t. So VC equal to, you integrate exponent 4 over 3t. Okay, QT for solving in terms for the VC, QT is 80t divided by 3. So time 80t divided by 3 dt. So factor out the constant 80 over 3, integrate exponent 4 over 3t times t dt. Okay, as just now, we have a product form. We will integrate it using a tabular method. This sign, this is u dv, t, then exponent 4 over 3t, exponent 4 over 3t, negative 1, integrate, so exponent 4 over 3t divided by 4 over 3 will become 3 over 4 plus the sign alternate, so this is differentiate 1 0, differentiate integrate one more time, exponent term become 9 over 16. 9 over 16 exponent 4 over 3t. Okay, and the result we have here. So the result, okay, we can interpret from the 80 over 3, okay, the result. T multiply here. So time 3 over 4 exponent 4 over 3t, multiply t. This one also you have, okay, exponent 4 over 3, you got the term 9 over 16 is actually 3 over 4 squared. So it's, okay, minus, okay, 9 over 16. With the second term is actually, so minus, here, plus C. First term, positive t times 3 over 4 exponent, 4 over 3 term. Okay, the second term, negative 9 over 16 exponent 4 over 3. So negative 3 over 4 times 3 over 4 all. So negative 9 over 16 times exponent 4 over 3t. So you want VC only, VC. So divide both hand side by exponent term. This is 20. So mean you have 20 exponent 4 over 3t times t minus 3 over 4 plus c. Okay. This term you divide by exponent 4 over 3t. This one by exponent 4 over 3t. Because initially this is exponent 4 over 3t times VC. You just want VC. So you divide both hand side by exponent 4 over 3t. Then you get the result. VC is 20 t minus 3 over 4 plus c exponent negative 4 over 3t. So this is a general solution. This one, general solution. Okay, and just now they gave also same thing when T0 VC equal to 0. Okay, then you have T0 VC equal to 0. So you got 0 equal to 20. T here 0 plus C, because exponent 0 is 1. So this is 5. So negative 15 means 0 equal to negative 15 plus C. That's why C is 15. So C is 15. That's why your VC is 20 t minus 3 over 4 plus 15 exponent negative 4 over 3t. Okay, this is particular solution. Okay, this is particular solution. Okay, and we can double check as we know okay, that I also equal to C times dVC dt. We're going to check whether the VC that we obtained correct or not. Okay, so we differentiate it to get dVC dt and we multiply by the capacitor value, which is 0.25, and it should be equal to the I that you obtained in example 1. Okay, once here, we find, let's say, dVC dt, dVC dt, I get only 20, so this is 1, this one, differentiate constant, you get 0, so differentiate exponent, you got negative 4 over 3 times 15, exponent negative 4 over 3t, so this is 5, so you get this is 20 minus 20 exponent negative 4 over 3t. Okay, this is dVC dt. Okay, if C dVC dt, the C is 0.25. So you get 0.25 is 1 over 4 times 20 minus 20 exponent negative 4 over 3t. And again, this is 5 minus 5 exponent negative 4 over 3t, which is 5 times, factor out 5 is 1 minus exponent negative 4 over 3t. Okay. So C dVC dt is actually equal to your current I. Okay, and it is actually, you check back with First example, your I is actually 5 times bracket 1 minus exponent negative 4 over 3t, which is tally. So here I conclude back scale for RC circuit. RC circuit, you can model it in terms of current I. So where we have VR plus VC equal to ET, VR is IR. If we want to solve in terms of current I, then VC is 1 over C integrate I dt. To eliminate the integral, we have the ddt per hand side. So ddt IR is R di dt. So 1 over C is constant, factor out. And then ddt integral I dt, you get I over C. So ddt E prime t. So if you model in terms of current I, the RC circuit will yield R di dt plus I over C equal to E prime t. And if the E prime t you get constant, then this equation can be separable and can be also linear equation. But if E prime t is not constant, it is only linear equation. Okay, if you model in terms of charge Q, so against VC, you put it as Q over C, VI is IR. Then you want to solve in terms of charge, I is actually equal to dq dt. So notice right hand side, this is EP. So this is, okay, if you want to solve in terms of charge Q. Okay, after you obtain the charge Q, you can check whether you, okay, if you find dq dt, it should be equal back to the I that obtained in example 1 when you solve RC circuit in terms of current I. And then this is, okay, how you integrate the Tabular method. Okay, if you have a integral of product form of either polynomial, exponential function, sin or cos function, you can use Tabular method. Is actually a systematical way of integrate used for integral by part. If you have the polynomial function is always chosen as u. So you differentiate until 0, sign alternate from positive, negative, positive, and so on. dv is your integrate. So you integrate exponent 4 over 3t, you get exponent 4 over 3t divided by 4 over 3 becomes 3 over 4. So this one, if you polynomial, you differentiate until 0. So the result integral is follow the slanting arrow. The horizontal arrow actually carry the integral symbol. Here, positive integral in plus positive integral 0 times this one is like 0. So if the u is not polynomial, let's say this is sin or cos, or this sin is cos, you just need to do 3 rows, and the third row will have the same form, the same term with first row, and the last row here is carry the integral symbol. So your left side integral and right side integral you combine together, then you can get the result. Okay, and lastly, okay, you can also model the RC circuit in terms of voltage. Okay, the cross capacitor VC, where VR is IR. So you want to solve VC, so VC you maintain. Then we know VC is 1 over C integral I dt, because for the series circuit, the current flow through capacitor and resistor are the same. So we are going to solve the I from the VC formula. So again, to eliminate the integral symbol, C is constant, I bring up to left hand side. So C VC equal to integral I dt. To eliminate the integral I ddt both hand side, so we got C dvc dt. ddt meet with integral dt, you just get the I. So plug in I is actually C dvc dt. So R C dvc dt plus Vc equal to Et. This is in the case if you want to solve in terms of Vc. So we plug in Rc value against, if the right hand side is not constant, you can get this is only linear equation. So linear equation, first step, identify your Pt, Qt. Second step, integrate the P respect to T. third step finds the integrating factor. I is actually exponent integral p dt. And then the solution for linear equation I, because you want to solve PC, so integrating factor I VC equal to integral I qt dt. So again, this case you need to solve it using the tabular method. Then plug in initial condition, you get the particular solution. Okay, we obtain the VC. It's actually the particular solution. Okay, and we know Ki is C dVc dt. So this one I just purposely want to check whether the Vc that we obtain is correct. So I differentiate ddt Vc, then multiply by a C, which is 1/4. Okay, notice that it's actually get back the I that we obtained in example 1. So with this, thank you for attention for this topic, RC circuit, where we model in our I, current I, charge Q, and voltage across capacitor. Thank you for attention.